So this is the lesson on writing balanced chemical equations. This first part, I'm going to ask you to copy down these notes. But it's important to understand what the point of this is. The writing a balanced chemical equation helps you understand that there are different ratios of the compounds involved in a chemical reaction. And accordingly, they must support the law of conservation of matter, meaning whatever you start with, you have to end with, all right? There must be the same number and kinds of elements on both sides of the chemical equation. So these are your 5 rules, 5 directions. Reactants, let me back up here. Reactants are always on the left-hand side. Products are on the right-hand side, and they are separated by an arrow in between. So take a moment, copy these down. Once you have those copied into your notes, let's move on. So this is the first equation we're going to try. The rules at the top, the directions are still the same at the top. I just copied them there. The equation we're going to look at here is this right here. It says solid calcium reacts in an aqueous solution of iron to sulfate to yield solid iron and calcium sulfate in the solution. So the first thing you want to do is you want to recognize the different symbols in here. There are state symbols that you can use. There are equation symbols that you can use. The first equation symbol you want to look for is something that says to produce or to yields. So that yield right there, that indicates that that is the arrow separating the reactant side from the product side. It says it's going to yield something, so that means everything beyond that, all of this over here, these are all going to be our products, which will be written on the right side of the equation, and everything to the right will be considered our reactants. And is usually an indicator that you have a plus right there, okay? Over here on the left it says reacts with or reacts in, that's also a plus. So at this point I'm going to start identifying my different components here. So the first one is solid calcium. Solid calcium, you just look at the periodic table and determine that calcium is the element Ca, and it's a solid, so I'm going to put the state symbol of S right there, okay? I'm going to put my addition sign here. Now I'm going to talk about reacts in an aqueous solution of iron to sulfate. Aqueous, understand that means AQ. Iron 2 sulfate. Well, iron 2, the Roman numeral 2, says we're working with the iron, and it is the +2 variety. Sulfate, from table E, you identify that from the polyatomic ion worksheet. Sulfate is the SO4, and that is a 2-. When you look at the 2 ions, we have a +2 ion and a -2 ion, so that will work out to be a 1-to-1 ratio. So when we write the formula for the compound iron 2 sulfate, it is simply going to be FeSO4, and it indicates it's an aqueous solution, so I'm going to put the AQ state symbol there. We have now reached the yield sign. We're now going to talk about solid iron. So solid iron is right here, and solid iron will be identified as just Fe with a state symbol of F solid. And, well, calcium sulfate. Well, calcium sulfate, we've identified what calcium is as an element, but this time it's an ion. So as an ion, calcium sulfate in solution, calcium is going to be the Ca2+ variety. We've already identified sulfate as the SO4 ion with the 2-. And again, we're going to have a 1-to-1 ratio, so the symbol will simply be CaSO4, and it says it's in solution, so we can assume that it's aqueous solution, since everything else was. And so now we have this equation, but it's not balanced. We have written the correct formulas for all the compounds. Step number 1. We have written the reactants on the left, products on the right. We now need to make a table to account for the different parts. The table I suggest you make is just a simple tabulation underneath the arrow that's going to help you understand what is on each side of the reaction. I suggest you start with metals, go to nonmetals, and then end with hydrogen and oxygen in that order. If it ends up that you have a polyatomic ion that is on both sides of the equation, keep it together. It'll make your life a little bit easier. So let's look at Ca is a metal, Fe is a metal, And I'm doing this right underneath the arrow. And then I have sulfate on both the reactant and product side, so I'm going to put SO4. Remember, that is the ion, SO4. I'm going to put that like that. And this tabulation is just this. It's just a tabulation. This right-hand side here, over here, that refers to everything over on the right-hand side of the equation, the products. The left-hand side of the equation, tabulation, is going to be used for everything over here on the reactant side. So we're going to start out by first identifying, okay, on the reactant side, I have one calcium atom. I have one iron atom in the iron 2 sulfate compound. And I have one sulfate polyatomic ion in the iron 2 sulfate polyatomic compound. On the product side, I have one calcium in the calcium sulfate compound. I have one iron by itself, and I have one sulfate in the calcium sulfate compound. And as it turns out, this is a balanced chemical equation. Now, I don't want you to confuse the different parts. What is the balanced chemical equation and what is the tabulation? The balanced chemical equation is not this thing down here. This is simply, I'm just going to group this together so it's stuck. Maybe it'll stay. This is just simple a tabulation. Your balanced chemical equation is this thing here in the box. This thing here in the box has the the elements, the four elements or compounds in here, and this identifies you with your coefficients. Now, you might not recognize the coefficients, but if you think about this, like in math, you never write 1x. These all have a coefficient of 1 in front of them. They're all the coefficient 1. They all have a coefficient of 1 particle. And what that 1 particle is telling you, that coefficient tells you one of 3 things. Okay? So we have our simplest whole number ratio. This is our balanced chemical equation. Everything within the box is what we're looking for. Coefficients tell you 3 things, and the 3 things they tell you are the relative numbers of moles, relative numbers of particles in a reaction, and if we have gases, the relative volumes of gases at the same temperature and pressure. So you would pause at this time to copy that down. This next equation is the same kind of a thing. I have the rules at the top. And so what I'm going to do is I'm going to encourage you to copy down the part in the green, and then we're going to work through this. All right, so it starts out, I'm looking for my ands and my yields and my produces. And so when I do that, I see a to yield right here, to yield. I see an and right there, and I see a react with right here. So I have the symbols that I'm looking for. So now I need to start isolating the different parts. So aqueous solution of sodium sulfide. If it's a compound sodium sulfate, sodium is going to be the sodium ion. It's going to be a +1. Sulfide is the anion of the sulfur atom. So that's going to be an S2-. So when we write the compound for that, it's going to have to be a 2-to-1 ratio. We're going to need 2 sodiums. Let me back up there, rewrite that. 2 sodiums for every 1 sulfur. And so the sodium sulfide formula is going to be Na2S. Since it's an aqueous solution, so we're going to put the state symbol of AQ there. Make my plus a little more definitive. Okay. We are now going to have reacts with an aqueous solution of cadmium nitrate. So we'll pull out that aqueous solution of cadmium nitrate. Look on the, identify the symbol for cadmium as CD. So CD is going to be a 2+. Nitrate on table E, NO3, 3, and that's a -1. So right away we can say we're going to need a 1-to-2 ratio, 1 of those to 2 of those. So we'll write the formula for that compound. It's going to be CdNO3, CdNO3, but we want 2 NO3s. We can't just put a 2 there. We have to put parentheses around my polyatomic ion. So we're going to have CdNO3, 2. It says to yield an aqueous solution of sodium nitrate. Sodium nitrate, okay. We know the sodium symbol is Na with a plus. Nitrate is NO3 with a -1. So we're going to have a +1 and a -1. So our symbol would be NaNO3. And it says it's an aqueous solution. We can put EQ there. And solid calcium sulfide, cadmium sulfide, solid cadmium sulfide. Cadmium's a 2+, sulfide's a -2. So we're going to produce a solid cadmium sulfide. So we'll do CdS because it's going to be a 1-to-1 ratio, and we said this is a solid. So we'll put it like that. So there is the correct formulas for all the compounds that has been written. We've written the reactants on the left, products on the right. So now we need to make a table to account for all of this stuff. Starting with our metals and ending with our nonmetals and keeping polyatomic ions together. So I'm going to do Na. I'm going to have Cd. I'm going to have S. And I'm going to have NO3 because NO3 is on both sides of the reaction. Quick table here. On the reactant side, on the left side, we have 2 sodium atoms. I have 1 cadmium, excuse me, 1 cadmium. I have 1 sulfur, and I have 2 nitrates. On the product side, I have 1 sodium, I have 1 cadmium, I have 1 sulfur, and I have 1 nitrate. Now we can see the sodium and the nitrates are not balanced. So in order to balance them, we're going to need a coefficient. A coefficient is the large number that goes in front of the compound. Its influence extends until either the plus sign or an arrow. So what I'm going to do is I'm going to put the coefficient of 2 right here. That 2, all right, that 2 makes it now have, let me move this down a little bit. It now makes it show that we have adjusted it so we have 2 sodiums and we have 2 nitrates, and now we have a balanced chemical equation. And our balanced chemical equation is this portion right here. That's our balanced chemical equation. It does not include the tabulation. Okay? So what you want to do for these kinds of questions, you have to work through the process. So again, you start at the top, write the correct formulas. That may be your most difficult part. Write the products on the right, reactants on the left. Make your table that accounts for them. Start balancing them. Use coefficients. And once you have the coefficients, go back and check. Do I have indeed the simplest whole number ratio? And these coefficients are 1, 1, 2, and 1. And so yes, that is the simplest whole number ratio. So this is how you want to go about balancing compounds in balancing a chemical equation.